All right, so question 14 on the review, which is 25 and 26 on the final, says find the perimeter of each polygon. One thing we got to remember is that tangent segments are those segments that if I was to make them a line, so they went on forever, they will touch the circle only once. So that's what the little point there means. It will only touch the circle once. So I have this tangent segment and this other one here. When two tangent segments meet outside of the circle, they're equal to each other. So this is 9.1. I'm going to say this other one here, it is 9.1 as well. If I look at the bottom, this one is 10, so this other one here will also be 10. Now, the whole segment at the bottom is 17.9. Part of it is 10. I'm going to say the remainder must be 7.9. So that means this other segment here, this other tangent, is also 7.9. The whole thing here is 16.6. Part of it is 7.9. Subtract them to find out how big is a remainder, and we're going to get 8.7, which means this other one up here is also 8.7. So I'm using the idea of tangents to find how much each of these little segments are. Now, on the perimeter, because this is the perimeter of the polygon, I notice here at the side, the whole thing is 16.6. Right? It was given to us to begin with. Here at the bottom, the whole thing is 17.9. Here on the left, the whole thing is 19.1. Right? Those I added the two small segments. Looking on the top, the whole thing is going to be 17.8. Right? I'm going to add those two little segments. So for the perimeter, add the four sides, add them all up, and you should get 71.4. Add the long sides, yes. You will need the little sides to find out how big the long sides are. Any questions on these? Question number 15. This one takes a couple steps. One rule. When a tangent and a radius intersect, they cross at 90 degrees. So here at the bottom, I see a radius. Here I see a tangent. So this corner is 90 degrees. When the radius and the tangent intersect, they make a 90-degree angle. Another rule is that a triangle, the three angles of a triangle add up to 180. Right? That's something we know. However, on an isosceles triangle, if two sides are equal, obviously to be an isosceles triangle, if two sides are equal, two angles are equal. Here I see that this side and this other side are equal. Because this is the radius of the circle, this is another radius, so I know those two sides are equal. That means that this angle with this other angle are also equal. I know that the whole triangle is 180. Let me take this 118 out of the way. So I'm going to go 180 minus 118, and I'm going to get 62. So these two angles combined are 62. I know they're equal to each other, but combined is 62. So I'm going to say each of them is 31. Right? 62 divided by 2. Now, let me take a look at a big triangle. I'm going to highlight it in red. You notice one angle is x, because I don't know how big is it. A second angle is 90, and the third angle is 31. So if I add the three angles, x plus 90 plus 31, it is going to equal to 180. Right. 90 and 31, I know that's 121, right? 90 and 31 is 121. Once I move it to the right, let me move it as a minus 121. So I'm going to get that x equals 59. Any questions on these? Question number 16, 17, and 18. For the instructions are find the measure of the arc or the angle indicated, and assume the lines which appear tangent are tangent. The idea, there's three things. That's why it says 16, 17, and 18. The idea the angle could be on the circle, right? The corner, if you guys see 16, the corner is right on the circle. The corner of the angle could be inside the circle or it could be outside of the circle. So those are the three cases. If the angle is on the circle, like question number 16, the arc that it creates, this arc, is twice the angle. So if the angle is 68, I'm going to say this arc is 136, right? 68 times 2. If I had the question mark here to begin with, then I'm going to say x equals 136 and I'm done. If I had it there. But I don't. In this case, I'm asking you guys for this other arc. These two arcs combined, the red one and the blue one, x plus 136, I said these two combined, it's a circle. And I know a circle is 360. So if x plus 136 equals 360, let me subtract the 136. I'm going to get that x equals 224. But the angle times 2 equals to the arc that it creates, right? 68 times 2 gave me 136. That's when the angle is on the circle. Now, when the angle is inside the circle, put this question right here, the angle, in this case x, I'm going to put it x by itself. The angle, in this case, it creates two arcs, 170 and 80. It creates two different arcs. So in this case, I'm going to add the two arcs, 170 plus 80 over 2. The whole fraction is numerical, so we can work it out. 170 plus 80 is 250. So 250 over 2, I'm going to call that 125. But once again, here on the outside, I'm always going to write the angle, whether it's x or a number. So, matter of fact, for me to explain what I mean, let's say that I gave you guys that here the arc is x, and let's say the angle was 100. So I'm going to make a different question. The way I will set it up, I will go 100, okay, that's the angle, 100 equals 170 plus x over 2. Remember, I'm always adding the arcs. The fraction I cannot simplify, because I don't know what 170 plus x is. So we cannot deal with fractions, get rid of fractions. Now when I'm going to get rid of them, I'm going to multiply both sides by 2. Because that way, those 2's cancel out. So I'm going to have 200 equals 170 plus x. And then you're going to figure out that x equals 30. But notice how here on the outside I have 100. On this one I have x. It's the angle, whatever the angle is. Whether it's x or a number, always start with the angle. Now looking at number 18, we're going to start with the angle as well. In this case, the angle is x. But in this case, I'm going to subtract the two arcs. So 17, I added the arcs. Here on 18, I'm going to subtract the arcs. So I'm going to go 148 minus 72 over 2. The whole fraction is numerical, so I can work it out. 148 minus 72, that's 76. Right, 76 over 2 is 38. So x equals 38. So question 16, multiply the angle times 2 and you got the arc. 17, you add the arcs. 18, you subtract the arcs. To kind of help you guys a little, for number 17, if you look at the two sides, there's one of them and there's the other one. Give or take, those are the two sides. They kind of make a crooked plus sign. So that's how you, like a hint, that's when you add. If you see the sides on the inside of the circle, they make a plus sign, like a little crooked plus sign, but there's a plus sign. If you look at number 18, inside of the circle, the side makes a minus sign. That's when you subtract the arcs. So that's kind of like a hint. When do you add? When do you subtract? Any questions on these? No? Okay. Now looking at question number 19, the idea is I'm going to get a circle and I'm going to look for a radius. The radius is always from the center of the circle all the way out in any direction. That's a radius. Then I'm going to look for another radius, which is obviously from the center to all the way out to the circle in any direction. As soon as I find two, we call it radii for plural, but two radius, let them equal each other. So I'm going to come from the center of the circle all the way out. I'm going to say one radius is x plus 9.3. That's the whole radius. Now I'm going to find another radius. I see a 28.2, so I'm going to use that. If the 28.2 was here at the side, I will say the radius is 28.2 if it was here at the side. But it's not. It's in the center. When I put the number in the center, that means that's the diameter. So 28.2 is not the radius. The diameter is 28.2. And then the radius from the diameter, I'm going to go 28.2 divided by 2. Remember, a radius is half of the diameter. That fraction is numerical, so we can simplify it. So I'm just going to write that x plus 9.3 is equal to 14.1. Right? I simplify the fraction. Let me move the 9.3 over. 14.1 minus 9.3, that gives me 4.8. But one radius equals another radius. Any questions on these? Now on the next one, I have a right triangle. So it says find the missing side of each triangle. And I call it right triangle because one of my angles is right. It's a 90-degree angle. And I'm giving you guys two sides, and I'm asking for the third one. When we do this, we're going to use Pythagorean theorem, which you guys know it as a squared plus b squared equals c squared. From the three sides, the important one is c. That's the important one. That's the hypotenuse. Sometimes the hypotenuse is x, sometimes it's a number. But c is the hypotenuse. The other two sides, one of them is a, one of them is b, doesn't matter which one's which. So here, the hypotenuse is x. Except the other two, one of them is a, one of them is b. Who cares which one is which? The way I'm going to set it up will be 9 squared plus 7 squared equals x squared. I know 9 squared is 81. 7 squared is 49. Now this is equal to x squared. 81 plus 49, that's 130. And that's equal to x squared. So if x squared equals 130, I'm going to say x must be equal to the square root of 130. On the instructions you have, leave your answers in simplest radical form. So simplify your radical if you can. The way I simplify it, I'm going to break 130 into two numbers. I multiply equals 130. I'm going to go 13 times 10. My 10, I'm going to split it as 2 times 5. If I have any groups, groups go outside, singles stay in. If you have any groups, my case, I don't. I don't have any groups, so nothing goes out. So I'm going to say x is the square root of 130. Right? Nothing goes out, so I just put it all back together. I just checked if I could simplify it, but in this case, I cannot. Calculators will give you a decimal, but I'm asking it for simplest radical form, not a decimal.